Okay, so this is question 5 from day 3. I thought I'd do this one because it's a normal distribution question with some inverse stuff going on, and a couple of you voted for part 2, and yeah, makes a bit of a change from Pims and Coms, which is what you guys mostly ask about. Okay, so as you know, or I've been telling you, or your teachers have been telling you, whenever you do normal distribution questions, you should always sketch it out. So over on the side, I'm just going to draw a little normal distribution curve for myself. I'm going to add on what the mean is, which is 6.5, and then I'm going to add for myself a little note that the standard deviation in this case equals 1.76. And then what I'm after is that 90% of the calls take longer than a certain time, which means I'm looking for a value down here above which the area under the curve is 0.9 or 90%, so that's my t value there. Okay, now the reason why you sketch it out is that you can see where it is, and so now you know that the value that you're after sits below the mean. Then you know that your value for z, when you look it up on the table, you're going to make it a negative z value because the value sits below the mean. Cool, so now you go to your formula sheet and you look up 0.9 in the middle of the table to find out what z score goes with it, except this is one of those critical values, so it's already on the table at the bottom of the page, and it tells you there that z equals, where is it, 1.282. So check that table at the bottom. They're the most common values that you might be asked to look up, and it'll save you some time. But as we said before, because we're looking at our value being below the mean, our z value actually is negative 1.282. Okay, so that's what we're going to use. We're going to use it in the z-score formula. So z equals the value minus the mean all over the standard deviation. So in this case here, negative 1.282 equals t, because it's the value that we're after, minus 6.5 divided by 1.76. And when we rearrange all of that, we get 4.24. That's to 3 sig fig. If you hadn't used a negative z-score in that, your answer that you would have got would have been up here, and if you sketch it out, then that could be a safety check for you that you've done something wrong, and hopefully your brain will kick in and think, oh yep, that's right, it's supposed to be a negative z-score. Okay, so that's the first part. Okay, so on to part 2. We want to find the probability that in a sample of 9, that more than 7 take a time which is within 1 standard deviation of the mean, blah blah. So basically we're going to do a binomial distribution question, so it's going to be binomial. Our n in this case is 9. Our p we'll get to in a moment, because we've got to work out what that is. And we want to find more than 7. So more than 7 would be the probability that x equals 8 plus the probability that x equals 9, because both of those two scenarios are more than 7. And of course the maximum is 9. So we're going to use binomial. We're going to use this. We need to know what p is. They tell us that it's got to take a time which is within 1 standard deviation of the mean. So all you have to do is remember that the z-score just tells you how many standard deviations the values are either side of the mean. In this case here, we're looking at z equals 1, both z equals 1 and both z equals negative 1, and we're looking at what proportion of the distribution is within that. So if I just move this up for a second here, there's 2 ways that you can do it. The easiest way to do it is just to use the z distribution, which is at the top of your formula sheet anyway. And what you want is to know what area is between 1 and negative 1 on the z distribution. So if you look up z equals 1, so just work out what it is for 1. When you look that up on the table, you are going to get 0.8413. Of course, that is the area of everything up to and including 1. So that's the area there, all of that. And you actually only want the part that goes back to the halfway, back to 0. So if you take 0.5 away from that, you'll get just that blue part there. So that blue part there is just 0.3413. And if you just reflect that over to the other side to get the area that's from 0 back to -1 on the z distribution, basically just times that by 2. So you're going to get 0.6826 as your p-value, your probability, to put back into your normal distribution equation here. Cool, so if we put that all together, move that up there, but let's just put that p-value there, so it's going to be 0.6826. You're just going to use the binomial distribution formula to work out the probability of 8 and the probability of 9. So the probability of more than 7 is going to equal 9C8, 0.6826 to the power of 8, and then 1 minus that, so 0.3174 to the power of 1, and then you're going to add to that 9C9, 0.6826 to the power of 9. Okay, and we work that out on your calculator, and you're going to get 0.167 as your final answer to 3 sig fig.